As you mentioned, thank you for having me here. And as you mentioned, with Traceable AI. And yes, I've done quite a few bits of things around development and security, product management for several DevOps tools, helped GitLab, put GitLab on the map recently. And with all my work in DevOps, it's become clear over time as DevOps has gotten more adopted that we really need to evolve. And this is not news to anybody here, that security has got to be a key piece of this. Now, security is wide, right? There's a lot of different places and things that we can look at. Even if we say application security, I want to kind of focus in on, as the title says, API security. Now, why is that? Because there's a new application landscape out there and is driven by APIs. So we're going to take in the next 20 minutes a look at what's changing and the kinds of things that we need to be thinking about with regards to that. So again, I probably don't need to say this to anybody who's on these calls watching this, but it's pretty well known that modern applications are driven by APIs. They're at the heart of innovation. We see articles constantly about this. We hear about this. They're allowing us to go from the monolithic world to this flexible, dynamic, ever-changing solution made up of microservices that we can change pieces of the system at a time and have resilience and have new features added without disrupting everything else. And so the innovation, the speed that we've all been pushing for, that business has been pushing for, has been answered with these new technologies. And the glue that binds them together is APIs. So they power the modern economy. I think there's no question there. Just a couple examples here of some of the huge microservices-based, cloud-based, cloud-native major solutions out there that have been successful. We all know this, but not everybody else does. And so development has seen the value and has adopted APIs voraciously. But in general, security has yet to catch up. We talk about it, and there's definitely work being done, but APIs is still kind of in its infancy with respect to what we're doing from a security perspective. So the current state of security in most solutions is out of date. It's solving for a world of the web clients of HTTP as the main protocol, in a different time when signatures were enough to catch the problem and to remediate it or block it. Problems like cross-site scripting, SQL injections, remote file inclusion, these types of problems, they plagued us then. We've gotten a lot better at blocking those and catching those, but they are still challenges today. But that's not the world we operate in anymore. So in the new cloud-native microservices-based API-driven application architectures, we've got tens or potentially hundreds of microservices that are now talking together, each of those potentially with its own set of APIs, right? And each of those APIs has its own business logic and is written by different people, potentially, who implemented who knows what level of security. So really what's happening is we've opened up a new attack surface, and it's a rich one. And these legacy solutions like OWASP and AppSec, they don't really understand the API layer. They're looking at signatures, and there's some work that they can do, but they don't really have the logic of what's happening, the business logic, the user tracking that's necessary to find and catch the kinds of attacks that we see are becoming much, much more common, including the business logic attacks like BOLA, excessive data exposure, mass assignment. These are folks on this call, this being an OWASP conference, are probably familiar with the OWASP top 10, or what I like to say, the OWASP web top 10. And there's been out since 2019 an OWASP API top 10 list, focusing just on the specific API type vulnerabilities that we find the top 10 most common. And these and more are the types of things that we need to really be thinking about. How are we going to protect ourselves against those? And to tackle these, what I'm saying here is that it's not enough just to see a piece of the puzzle. In the previous talk, we talked about how the bad guys are using AI more. This is very true. they're able to go through large amounts of data and hit large attack surfaces very efficiently. We need to be able to do the same. But what's more, because the complexity of how we communicate between all of the pieces of our system has gone up, we need to also have new tools to help us better stay on top of the security of our systems. Tools that need user tracking, as I mentioned earlier, and deeper application context. And here's the thing, right? We didn't just get new attack surfaces and new attacks, but there's all sorts of new other types of challenges, complexities with how we work with APIs, how we manage them, and how we troubleshoot APIs. You know, there's some great API management solutions out there that have pioneered making that better. And there's solutions like API gateways that are also great for helping us to make sure we're authenticating and rate limiting and whatnot. But we also have this new challenge of API proliferation, right? Got a microservice, need to get access or give access, create an API, right? We get shadow APIs, things that have been retired or older versions or older systems that are sitting out there that are vulnerable. External exposure when we didn't expect it. Maybe it started as an internal and then it became an external, and so it had less authorization on it. With data exposure is higher because these APIs are now actually talking more directly to each other, more directly accessible to our data, right? And so now data exfiltration and data exposure is becoming a bigger challenge. And so the context, the business logic in these APIs, how they are pretty raw to the business logic. And so there's a lot of room for making simple mistakes that can have big repercussions. And then troubleshooting, because we're in the cloud space and we have services talking across so many different systems, troubleshooting becomes a challenge. So if you look at the headlines in the last several years, you can see that companies like Apple and T-Mobile, multiple times, unfortunately, Uber, Twitter, Facebook, Shopify, Starbucks, you can name all of the big companies. They've at some point recently been burnt by an API-related attack. Here's a quote that blows my mind, right? This is from Security Magazine last year. 91% of organizations had an API security incident, well, last year. So this is from February 21. That blows me. 91% had some sort of API security incident. That should be taken to heart here, right? We know what the new battleground is. We need to make sure that we're still protecting all the other battlegrounds, but we also need to make sure that we're taking care of the new attack surface. You know, and I'll bet these companies had WAFs or RAFs, and they had sophisticated security teams. Gartner predicted that by 2022, that APIs would be the most frequent attack vector for data breaches. Right. And so we have two different pieces of data telling us, actually many more that are not listed here, telling us the same thing. So why is this happening? How is this happening? So we'll start really simple, right? APIs are great for attackers. It's really that simple, right? There's a large attack surface. You know, a single service can have tens, hundreds of APIs. They're intent on oversharing because we want people to use our service, and the way that they're often written and what the languages help us to do is to be efficient as programmers. Well, what does that mean? That might mean that I send you an entire JSON object with all of my all of my users' data and let you parse it out, because it's really easy to just send the whole JSON, right? But that may not be the right thing. And then the other piece about APIs is they're predictable, right? Common protocols like REST tell us how we should structure our API calls. We can go in, an attacker can go in and make some pretty good guesses on what they're going to find and what they can poke at. And so that is a part of the problem. Now, we've done many attempts to solve for API security to use tools that we have to help us with API security, things like doing static application security testing and dynamic security testing. And those are good. All of these tools are important, but they're not enough by themselves, because things like SaaS are looking, at the static code. They can't see what's happening, and DAS, even though it can see the runtime behavior, it doesn't understand what the runtime behavior should be, and it's reliant on developer-generated documentation that quickly gets stale or goes out of date. Things like bug bounty and pen testing absolutely important to do. They don't happen frequently enough, and unfortunately, they're not usually comprehensive enough. Now, they catch edge cases, which is important, but it's not enough by itself. API gateways, I mentioned earlier, great for doing API management. They're not really built for security. They can do things like rate limiting, but they lack the user behavior, the business logic of what's happening with the APIs. And WASP and RASP I mentioned also earlier, those are signature-based typically, and they require a lot of maintenance to keep those signatures up to date, as well as adjusted for the business logic of, actually they can't even see the business logic, but as well as adjusting the signatures so they match the changes in the applications, which are changing more and more frequently. So important solutions to have, but not enough by themselves. So let's dig a little bit deeper and kind of get an inside look on like, what are we talking about here? Why is it different? So we're not talking about any real companies here. So we have a company that deals in automobiles, and we'll call them Goober, and they had an API data breach. Now, what's supposed to happen in this situation is a new driver that is joining on a referral can go to a particular API, and they will get back, they want to say, I want to sign up, and they'll get back a user ID. Now that's generated by the system. Now the system is expecting that that client is going to now take that ID and make the request back, give me the user object that you've now filled with all of the data that I've sent you. Okay, that's what's supposed to happen. 1, 2, 3, 4, 5. In the attack scenario, the attacker will first authenticate, so they are authenticated to the system, and they will send a properly formed API call back to the system, but they'll ask for someone else's ID, 5, 6, 7, 8, 9 in this case. Now, if there's a mistake in the authorization, maybe it wasn't written in, maybe something is broken, then that API will turn around and say, yep, you are authenticated. Here is the data object for this user, 5, 6, 7, 8, 9. Now, there's two things going on here, actually. What happened? The attacker got access to private data that are in the record that was sent back. They got authentication tokens, which are also in the record, and they were able to do a full account takeover, would have been. This is all theoretical. Now, the two vulnerabilities, very common broken object level authorization, where as I described earlier, the person was authenticated, the user, but they were not authorized to see somebody else's record, but that authorization check wasn't done, so the object was sent. That paired with, and often commonly, with excessive data exposure. Now here's where the API responded with the full JSON object for that user with all the details, expecting the client will do the proper thing and filter out just the data that it needs and ignore all of the other data. Well, there was private data there and the client was rogue, so access. And so this is an illustration of some of the challenges, right? Those are properly formed API calls. They look fine, no problem, right? But it took a system that, or would take a system that could understand what is the intent, what is the user, the usual user behavior, and what is the usual API behavior that if we see, for example, an ID coming back into the system that is not the ID that was originally requested. And so these are things that many current solutions cannot catch because they are not built to catch them. So really a new generation of application architectures has brought us this new level of attacks. And you may be thinking, come on, people aren't doing this, right? And no, developers and folks that are creating these systems, they're not creating these problems on purpose, right? Things have gotten more complex. We don't have all the tools to help us. You may hear things like, it's an API from Amazon, so it's secure, right? I'll just use it. The API works, but I need to modify it right now and ship. So quick little change there because it's ours, but or I'll document that later, and then somebody else doesn't get what they expect. I need to make a quick API without designing it. Don't have time. That's where we can make mistakes like not authorizing properly. This is an internal API, so I don't need to do as much checking, right? true until it becomes an externally facing API, which can happen like that without realizing it unless something's watching for that. And this API gateway already authenticated them, right? So I don't need to worry about that as a developer because somebody else is doing that work. Better make sure that's true. So these are kind of some common things that can lead to these types of issues becoming prevalent, which they are. And really what this comes to is, we've gone through several application security generations and the tools keep advancing. And really what I'm saying here is that we're at the point where we need the next generation of tools. The solutions that need to be API centric because they need to understand the API inventory, which ones are more risky, which ones are being changed, which ones are new, and what's being introduced versus not, which one's flipping external versus internal. We need to have learning solutions. Again, previous presenter was talking about this, right? From the perspective of the bad guys are using AI too, so they're moving fast. Well, yes, that is also true. But even just looking at the speed with which we're now developing, right, with which we've been unlocked to move because of microservices and because of APIs and because of DevSecOps and DevOps and whatnot, right? We are moving faster. The applications are changing faster. The APIs enable pieces of the application to change at the same time, and the attacks are changing too quickly for a rule-based system to keep up, which means you need AI to help. We need a system that has an understanding of the data flow and the risk of that data flow, because we're not anymore just sending data from one trusted server to another. Now it's handing off from microservice to microservice and getting changed along the way. And we don't know necessarily the security of all the downline services unless you can track it and you can understand the flow of that data and see when it goes external or see when it gets handed to a questionable or risky API. Right? And it needs to protect and adapt this tool at the speed of DevOps, because that's how fast we're moving now. If we're going to have DevSecOps, and security needs to be able to adapt as quickly as new changes are coming out. And then there's, last but certainly not least, is it needs to have holistic visibility. And we're going to talk about that a little bit next. Why holistic visibility? Well, the application context is key. The user behavior is key. How the APIs behave over time is key. And so that's an important part of holistic visibility. So I'll switch gears here and talk for just a second. To pay this off because it was in the abstract. The deeper we can see, the more we can understand, and the better we can then therefore protect. So if you think about a colonial doctor, a doctor of the olden days, they did external examinations. Hit the knee, look at the person, feel the temperature. It's all external, and they did the best they could with the tools that they had to diagnose and try and help people. Okay, but modern medicine knows this as well. That the deeper that we can see, the more we can understand, and the better we can protect or heal in this case. And that's why we have tools like ultrasounds and CAT scans and MRIs, so we can see what's going on inside to understand and heal better. So what does this look like for an application? For an application, if we think about it externally, we might have things like, if we sit on the outside and watch the traffic, we might have an understanding of like what devices or who's contacting us, the identity, like in this case, the IP address. And that would give us a view. We'll be able to see the edge API activity, the API edge calls. And the services, the data that's actually going to external services or coming in from external services will have that visibility. But now, if we add the internal view and we extend our visibility, we have roles and permissions. We start understanding more who is supposed to be able to do what. For example, maybe I can send to that API somebody else's address because I'm an admin, right? We get better visibility to the internal API calls and the sequence of API calls, so we can understand from the user all the way to the data and back actually what's happening. We can trace the conversation, and we can see where data leaks. We can see where there's a problem. And so data gives us, seeing internal view gives us that access to the internal data flow and to understanding what happens between our internal services as well. So we get a more holistic picture. And then finally, being at the code level gives us the ability to understand the parameters and how they're being used, how they're changing, and what's common for them. What is the request response data and the errors and the latency that each of them is experiencing. So we get more ability with deeper visibility to protect. And this is a lot of data. So that's where the AI comes in, because this data should be fed into a security-focused AI. And that security-focused AI can then look at all of the data from these different distributed tracing points and start and bringing in internal and external factors together and start getting a sense of how the API should behave, how the code should behave, what's normal user behavior for this application, what's the risk of the different APIs in the system, what's the data behavior, what do we expect that to do, what does it look like typically, and which users, quite frankly, should we trust, because we're watching the users, right? And if we do that, then we have the ability to do all sorts of protection that's beyond what we can do if we just are looking at signatures, or if we just have a partial view of what's happening. So is this useful for multiple teams? Yes, it is. Many teams with specific needs, one team with specific needs, DevSec and Ops, the developer can get better troubleshooting and find out when they're going to have risky APIs before they release them. Security can keep on top of the changes and do deep forensics and threat hunting with the data that gets collected. And Ops, of course, is going to be looking at performance and management of compliance checking and auditing and whatnot, and troubleshooting and root cause analysis. And so the more holistic data we have, the better we can protect and secure our systems, especially when it comes to APIs. So again, I'm Dan Gordon. I'm with Traceable AI. If you want to see a demo or check out what we've got and sign up, you can get a cool shirt. Like I happen to be wearing one. Or contact me. My information's there. I'd love to talk to you more about it. And I think with that, I'll switch over to Q&A.